Hi, everyone. Thanks for being here on what I call the migrations framework, or in the long sentence, migrations and understanding Django's relationship with its database. Sorry for the logo of my employer. Don't worry, this won't be an advertisement talk. I doubt anyone would even be interested in the solution. But however, I think the slide templates looks really neat. So just ignore the logo and let's keep going. So first of all, David, briefly introduce myself. I'm just a little guy doing some Django, trying to roll up my sleeves from time to time and get my hands dirty. French German, I live in Paris. I work at Spotify, the purple company with the cool slide template. And I worked a little bit on tooling around Django migrations. So I'm going to try and share around that today. So our plan for today is going to be in 4 steps. First, we'll introduce a bit Django and its migrations, try to get up the basics, and have this little toy project we'll use for this workshop. We'll talk a bit about the theory behind it, then we'll try to add some features to the project, like you would do, like any Django developer would do actually when you're working, and we may run into some issues, and so we'll try to understand those, formulate them, why we have those issues, and try to understand them. And then finally, of course, we got to suggest some solutions, how to prevent them. So I'm not 100% familiar with the remote workshop format, so I might be moving quite fast sometimes, maybe too fast. Don't hesitate to ask in Slack in room secondary if you have questions and that's not obvious. I'll try to keep an eye on it. There's also going to be some live coding, so I'm going to do all the changes in my terminal too to illustrate it. So you can do all the changes on your side too. It's always easier to write code yourself and execute command line commands yourself than just looking at it. So feel free to do it, but I'll be also doing it on my side. So the requirements, you might have seen them, maybe not. It's not mandatory. We'll have a little Django project. You can clone it. It's on this link. You can install the libraries you'll need, which is mostly Django and database driver for MySQL or PostgreSQL, have a database running, configure it, and basically run migrate and run server to check if it works. So a toy project is about trees. Why? Just because they're pretty cool. It's sustainability, this ancient creatures. Well, I like trees. So the Django project is just a bare project with one app called trees. There's one view, URL, and template, which are all linked and accessible under /forest. And there is a basic tree model with the first migration that creates a tree with a name. And that's all. So let's get it up and running. I already have a little terminal here where I have most of the project already set up. So I cloned the repo, created a virtual environment, all that. And I'll just run migrate to see if that works. Okay, there we are. It migrated. Now I'll run server to see if that works. And let's go here. And we're going to go there. And the server works. Okay, perfect. If we go on the /forest, as we just discussed, we see that we have a very nice looking page with a lot of CSS skills here. My forest is composed of nothing, and we can create a tree. So I create an oak tree, and I have a tree. Okay, perfect. Very easy, simple toy project. So the very basics of Django migrations, you might know them. These are 2 commands, make migrations and migrate, that you probably know of by heart. I mean, they're dealt with in the official Django tutorial in part 2. So it's just after part 1, creating a project, part 2, doing migration. So it's essential, and rightly, it becomes a daily part of your life as a Django developer. Let's take a step back and see what's a migration, what are they used for? So a bit of theory. So Django defines itself as an MTV framework, model template view, which is known by ordinary mortals as MVC, model view controller. And which interests us here is the model layer, which is here to interact with the database and abstract it from the rest of the application, so that you don't have, as a developer, you don't need to write the SQL statements to manipulate the database. The framework will do that for you. And how does Django do that? Well, there are Python classes, as we just seen, the tree class, and that these classes will represent the model layer, which pretty appropriately inherit from a class called model, which will handle this this model layer, which is the database layout actually. So these Python classes will be there to represent what the database should look like. So little quiz, if you will give you not like 15 seconds to write in Slack if you want. So what are the two types of operation that a framework, in this case Django, would need to abstract entirely the database? There are two types of operations. What do we need here? I'll wait maybe 10 seconds, not much longer. So the first type is CRUD operations, data manipulation. It's and there Django comes with an ORM, an object relational mapping, which is super powerful. You already used it, probably 3 objects also. You're creating all these Python objects, and they will be fully loaded functional objects with everything that's filled. So here we would have 3 objects with the name that is filled, and that comes from the database. And you didn't have to know what database, how does it work, what do I do? And you can do all kind of data manipulation with the ORM. The second type are schema manipulations. So that's all what's about metadata around the data itself, the tables, the columns, the types, the constraints, indices, and whatever. And these are handled through migrations. So why do we need these migrations? So what's required for this ORM to work correctly under the hood so that we can just use it without having to think of what it's actually doing? I'll give the answer straight away. It's that the database table should contain all the fields from the Python model class. So if we have a driven name, we actually expect some table in the database with the column of names. So if we put that the other way around, is that all changes to the Python model, these classes, should be passed on to the database schema. And that's what a migration is. It's the sequence of operation that will apply the changes from on the database and the Python class onto the database, and that will get the database from one state to the next, to the one that Django is actually expecting. So when you take all migrations of a project, you have this graph of migration that will actually take an empty database to the final state that is mapping the model classes inside your code. So that's very short introduction of what's the migration framework and how does it work. And it's super useful. It's very iterative, and that's why Django is a framework for professionals with a deadline, because your requirements are always changing, so in your code. And here you're able to modify your code in your classes easily without having to think about what does my database schema look like actually? What SQL do I have to write? Is it the PostgreSQL syntax? Which one is it? You just have to change your Python class, and that will be applied automatically. It's consistent in the sense that it's run in a migration, and we won't go into the details of your consistency model chosen in the database, but in most cases, everything will go fine by default. You also have a deterministic output, but that can be altered through the last point here, that the migrations are very flexible. That you can run any, you can modify your migrations manually. You can write raw SQL statements. You can execute any Python code too. So you can basically do whatever you want. So that's all cool, all great, but let's dive into the real stuff, like what this my workshop is about. So far from forgetting to run make migrations migrate, which happens to all of us all the time, let's explore some more pitfalls. So to our trees project, a new feature is needed. Our users want to also store the height and the plant year of trees. Okay, well then, let's go into a terminal. I'll go into my editor, into my trees models. Here we have the actual model. I'll add a height, which is a positive integer field. Perfect. It's going to be nullable because we might not know. Oops. we might not know the height of the tree we already have in our forest, and we'll have a plant here. And here the requirements are, we don't want a null value, we always want a default that's going to be 0 if we don't know when it was planted. Okay, good requirement. I'll save this. I'll make the migration. I'll stop the server for now. I'll make the migration. It created a migration, the migration number 2 with both fields. I'll migrate that. And I'll run the server. Okay, let's load our forest again. So our oak tree has no height and plant here 0. Perfect. If I'm adding, let's say a pine of height, there's no unit, but let's say 200 of whatever, and then 2010. Works like a charm. Perfect. Our feature is up. We just implemented the new feature that was asked. Let's wrap that up into a nice pull request, as we would do to get some code review, and that our coworkers can have a look at it. So I'll check out a new branch that I'll call feature. I'll add both fields, both modified files. I'll add a comment, add height and plant here to the tree model. Perfect. And I would push this. I would create a merge request, pull request, whatever, so that coworkers can look at it and say, hey, adding these 2 fields is fine. Perfect. Well, that's sweet. Okay, let's go to the next task. Oh, our first bug. We already have a bug on our platform. That's unfortunate. What does the task say? A user from Colorado tried adding the Rocky Mountain bristlecone pine, which is a 31 characters long name. Oh, you could have seen that one coming, right? So by the way, this is what this pine looks like. And okay, let's fix that. We should have thought of that earlier, right? We're gonna increase the size of the name to 100. Let's say that will be enough for now. I'll go back to my terminal. Let's check out the main branch, because we'll do the fix right on the main branch, so that, well, we want this bug fix to be released as fast as possible. I'll reload my model file, and I'll increase the max length to 100. Perfect. I'll save that. I'll make the migrations. It altered the field name on the tree model. Perfect. Now I'll migrate this. It worked as expected. I'm going to comment it right away, because that will be easier for later. But basically, I would say, okay, my bug fix is done. We'll test it just after. Say, okay, that's fine. Let's commit this and say, okay, bug fix. This is not a good commit name, but for the workshop, it will be enough. Let's run the server and see if that worked. So here we are on forest. I'll reload this. The 2 columns are gone since they're in the feature, obviously. And now I'm going to add the Rocky Mountain bristlecone pine. Let's create that. And it didn't work. Oh, we have a null value in plant here of relations tree. That's violating a not null constraint. So this is an error that you often receive in Django when you're developing features. Marcus Holterman discussed it 2 days ago in his talk about writing safe database migrations. It's a common case here that you might encounter. So what does our code look like? We have a name of length 100. What does the database table look like? So here I have a screenshot of the inspected database, and we see 4 columns, the ID, which is auto-generated by Django. It's always adding an ID, which is the primary key of the table. The name, which is of size 100 and cannot be null. Perfect. The height, which is an integer and is nullable. And the plant here, also an integer, which is not null. So the error says, yeah, okay, plant here cannot be null. It has a not null constraint. That's true. Okay, this makes sense. But wait a minute, didn't we specify a default value to our plant here? We said it was 0. Well, time for a little stop in our feature development. Let's learn about Django and its default values. So it was already touched on 2 days ago by Marcus, but let's look at it again. So here's a new command in Django, which is called SQL migrate. So when you run a migration, when you migrate it, Django is generating SQL statements and executing them against your database. With SQL migrates, you're seeing what are the SQL statements that are generated and executed. So here we have a little snapshot of the features branch, the migration number 2, which is adding our both columns, our both fields. And we see that for the plant here generated 2 statements. First of all, it's added the column plant here, which is an integer with the default value 0. It's not null, and we check that it's positive. And then second, we drop the default value. So here Django is first adding the row and filling all existing rows with the default value, but then it's dropping it. Why is Django doing that? Well, we discussed it just before that Django is very flexible about its default values too. There can be any Python function, and any Python code means it's not trivially expressed in SQL. For instance, it could be calling a third-party API. How would you translate that into SQL? And even further, how would you translate that into different SQL dialects? I'm pretty sure PostgreSQL and SQLite do not have the same feature set for default values. So that's why the key takeaway that's written in bold here is that the default value in Django is handled on the application side, not by the database. Application side meaning it's the framework, it's Django, it's the Python code itself, which is handling the default value. So it's Django that will see, hey, you're trying to insert a tree that doesn't have a plant here, it has a null value, but I know that I should substitute this null value with the 0. And then you do an insert statement with the 0 value, and the database is accepting that. So you might wonder here how does Django fill the existing rows with a value if it can be any Python function? Since here we still generated an SQL statement that will actually have a value and fill the existing rows. Well, here in this case, we just have a default value that's a 0, so it's pretty easy to interpret and to substitute. But if it would be a third-party API call, or maybe we want to fill all existing rows with random values, the default value would be a randint function, and Django would execute it just once to create this SQL statement. And then all new rows would actually execute the function, which means that all your existing rows would be filled with one and the same value, even though you define it as a random integer. But then all new rows will really apply this function and have a real different default value. So the key takeaway here is obviously that it's Django that's handling the default value. So when I switch back to the bug fix branch, well, Django wasn't aware anymore of the plant here, so it didn't substitute the null value. The null value wasn't even in the insert statement, and it just failed. Okay, so how would we fix that? Here are a bunch of different solutions with pros and cons. I won't go over them in general. You'll get the slides just after the talk. But some of the solutions would be check out the feature branch and run the reverse migrations. That sounds simple. You just come back and drop the columns. That has some drawbacks, which would be that you're dropping the data that's inside these columns, but that could be fine. I could manually revert the database changes, just connect to my database, and if I know how Django works internally, I could drop the columns and edit some other tables so that everything's just as before. That might be faster if I'm familiar with this. An easy way is to drop the entire database and recreate it from scratch, which would work just fine here since we don't have that much data and we just have 2 migrations. But if you have 1,000 migrations, that might take some minutes. Or you can have a real default value as a database default, but we'll see that a bit later. Let's go with solution 1 here to fix our bug. We'll run the reverse migrations and undo adding these 2 columns. So let's go back to our terminal. I'll stop this one here. I'll go back to the feature branch, check out feature. From here, migrate, Python manage py, migrate the trees to migration number 1. So that unapplied the last migration. So now if I come back to my main branch where I have the bug fix and I run the server, I'll go back to my forest. Let's try again this Rocky Mountain bristlecone. We get it. We create it, and now it works fine because we dropped both columns and we don't even know the plant here exists in the database. So that's happy. We'll now wrap this commit up also in a bug branch and get it merged into production so it's released and our Colorado user is happy. So let's imagine we do that, and now let's rebase our feature branch, right? We want to move forward and also fix that one since we know it won't work with this. So let's go back to our feature branch and rebase it against the main branch. So we'll do that real quick. We'll do a rebase main. There's a little conflict, obviously, because the name column is not the same in the model. So here I reloaded the tree model. And I want to keep my name with length 100, remove the name with length 25, and keep our two columns. So we have and the bug fix and our two new columns. I'll save this. I'll add the trees model, and I'll rebase continue to end my rebase. Okay, perfect. Let's test again our feature. Let's migrate it again. So we added two columns and an error that you might have encountered quite often, missing merge migrations. So we have a conflict in our migrations. You know this, certainly. You worked off a certain version of your code, and a coworker or maybe just another feature you're working on is also of the same version. You both create a migration, and when you merge them, you have this conflict saying, hey, Django doesn't know where to go. We said it before quickly that migrations in Django are a graph. Each migration might depend on one or multiple migrations. So this creates a graph, which Django will then discover and go into the leaf nodes to know what is the state that represents all my model classes in which I should be, in which the database should be. And here, as we can see in this little chart, right, Django cannot know, should it alter the name length or should it create both columns, right? Both are valid states, but it cannot know which state is the final one that we expect. And it's we as the developers, the engineers behind that know, okay, it should be both actually in this case. So we have two solutions here. First of all, the one suggested by the command is running a make migrations merge, which is creating a little merge migration, which is basically saying, hey, both of these migrations have to be applied, and the last valid state is this very last one, where both are already applied. This is pretty easy and straightforward, and will work in nearly all cases. But it might create, well, the graph is not as nice, even more if you have a lot of developers working and you have a lot of merge migrations, which will conflict with other migrations that can create a migration graph, which can be quite a headache, but Django is handling that, so that can be fine. Second solution would be to bump the last migration. That creates a pretty clean and straightforward migration history, but you might have some issues on your database if you actually already applied these migrations and you try to run again a migration doing the same operations. This might fail. So it depends on your case. If for example, you're running on, you created the height and plant here on multiple environments already, maybe different tests, sandboxes, staging environments, pre-production, then you might want to go with the merge migration, because bumping the migration would need to either unapply the migration on all these environments so that it works, or faking the new migration everywhere. We'll go here with bumping the migration, since we know exactly what's happening. It's just applied locally in our dev environment. So let's rename the migration. I'll go back to my editor. I'll go into my migrations. It's the number 2 auto migration, and I'll rename it to 3. And inside the migration, I'm going to change its dependency to migration number 2, which is called alter tree name, if I recall correctly. Let's save that. Let's go back here. Let's try to migrate again. And that worked. Okay, perfect. So quick parenthesis about how does Django know if it needs to apply a migration or not. It's quite simple in the end how it's implemented. It's a table in your database, which is called Django Migrations, where Django will store a row, an entry for each migration that it has applied. So here's a screenshot of just before migrating here, this last, this migration number 3 of what it would look like. So when migrating, Django is executing the content and adding a row here, telling itself, hey, I applied this migration successfully. There's a keyword argument, a parameter to migrate, which is fake, which will actually prevent the migrate from executing the real operations, but will just add the row here, telling Django, hey, I applied this migration, but you have to be aware, okay, it actually didn't run them. So that's in the case where maybe the columns already exist and you know that, so we just want to fake it and add a row here. You could also add it manually if you're a cowboy. Okay, let's keep moving. I mean, let's go to our next feature. Project is never finished, right? So actually, someone's telling us in the company the plant here is not precise enough. We actually need a complete plant date. Yeah, that sounds fair. So I'm gonna edit my code, right? I'm gonna go here into my model again. And I'm gonna edit the plant here, remove it. I don't want a plant here anymore. I want a planted on date, for example, which will be a date field with the default value, which is the today date. So date.today, and I'm gonna import from the famous datetime built-in module date. Okay, I'll save that. I'll go back here. I'll run a migration. It created a new migration number 4, which is removing the plant here and adding the planted on. Perfect. I could migrate that. I can run a server. Whoops. And check if that works correctly. Let's go back to forest. I'll reload it. So we have the height, which is none everywhere, even for the pine, because we created it and dropped the columns and recreated it. So it's null by default. And we have the planted on, which is June 4th. And yeah, that works fine. I could add another one, maybe a bird. And of height 150, that was yesterday. And let's create this already very big tree for, for the plant date. And okay, that works. Now, if we imagine the very same case as before, where I would have to switch to another branch, maybe the version just before with plant here, you might see it coming, you'll get another error, right? For the same reason that we just dropped the column, that's the plant here, and the previous code would try to add this column, but it doesn't exist, so that would fail. We won't do it here, you can do it yourself to see by yourself, but we're running into another issue. So how will we drop this column? We don't want it anymore. One possible solution to that, and I heard many times, especially by DevOps or infrastructure teams, which are in charge of releasing, for example, your application and deploying it to production, they're often telling you, hey, your code stopped using plant here, this field. So the code is now not aware of it. And let's just not drop it in the database, since the code will just ignore this column. And in the case of a rollback, which is a very good thinking from their side, is if we roll back, the column still exists, and we don't need to restore a backup and just this one column from the backup, which I don't know from when is the backup the last time, is it up to date? So let's just keep it. And since it's ignored, it should be fine, right? Well, what's the issue with this reasoning? It's not completely incorrect, but we are omitting the fact we've seen just before. The default value is set by Django. but Django won't know about this column anymore, as they just said. Plant here is gone. Django will ignore it. So it will try to add a null value, but it's not nullable field. So keeping it would actually crash on insertion. So that's a pretty bad bug in the sense that you won't detect it in development. In development, you'll say, okay, I'm just running my migration, I'm dropping the column, everything works fine. But in production, you will try to do something that you thought is smart, but it will actually crash on every row insertion. So let's take a step back and look at what's the issue with all these problems we just looked at. So, okay, a lot of errors, they're bad in development. It's okay to just slow you down, but you can fix those. And to represent that with a little boxes, here we have the code and database version 1, code and database version 2. And you see that code version 1 cannot work with the database v2 since plant here doesn't exist, and so it has been dropped. And the code in version 2 has a column that cannot work in the database version 1 since the column doesn't exist yet. So the main idea is that Django in the migrations expect the synchronicity between the code and the database. That's very important to know. It's why Django is so easy to reason about, and it eases the cognitive load of when you're working, of when you applied when you created and applied all your migrations. Well, everything will just work fine and as expected. The real question is it possible to actually keep the synchronicity between code and database? Imagine a production environment where you're scaling horizontally. You can add servers. You just have REST API with no state that can you just pop, snapping your fingers and have 10 more instances to handle your load. Well, we just said that when I'm updating my code, do I update first the Django code or first do I apply my migrations? So this was also touched on by Marcus' talk 2 days ago. If I update the code first, well, that cannot work. I'm adding a new column and it doesn't exist in the database. That will just plainly crash. And if I updated the database first, well, it dropped the column, so that also doesn't work. So I would have to update them at the very same time. And that the more databases and servers you have, the more difficult it will become. It will be very hard to have the deployment at the exact same moment. And so it will basically, you don't have a choice but to generate downtime so that you can update them one after the other as fast as possible. But downtime is not acceptable to everyone, right? There's another case where this will, even if you would be able to deploy at the very same time, there's another problem if in an environment where you have multiple versions. Let's imagine you're selling a stable version of your software, V1 that only get bug fixes and you don't add features to it. But it's targeting the same database as an agile version you also sell, that this version has continuous deployment and it gets new shiny features every day, every week, every month, what do I know? So if now I had to apply a migration for a new shiny feature, and that will break the database for the older version, for the stable version, that's pretty counterintuitive, especially for customers. If the unstable version is breaking your stable version, that's the opposite of a stable version, actually. So we will have a problem here in all cases. So what can we do? Are we doomed? Of course not. Of course, we just looked at one specific type of migrations here, which are backward incompatible migrations, meaning that when we apply them, the code prior to this migration will stop working. There are, of course, a lot of backward compatible migrations that we can add. For example, adding a nullable column to a table will just work fine in many cases, and that will be no issue. But here, adding a not null column that won't have a default value, or dropping a column, or renaming a column, maybe changing its type. These are backward incompatible migrations. And they are here in this case, the source of our problems. So what can we do? What can we do? Well, first of all, we accept our faith and say, okay, I'm just running a little application with one server, one database. They may be even on the same machine. I'm fine with a few seconds, maybe a few minutes of downtime. I'm happy to fix the environments manually, but I like this trade-off, or well, be able to actually drop columns when I want to drop them, or rename a field when I misnamed it in the first place. That's a fair trade-off. However, would be careful in the sense that even though you're okay with some downtime, maybe 5 minutes it's possible. If you have backward incompatible migrations, they're also very cumbersome to roll back, meaning it will double the rollback time in case you have an error. So first, deploying might take a minute or two, maybe later will take 5-10 minutes. Then it will take 10 minutes to see, okay, we have a bug in this release, we have to roll back. And then you need 10 minutes more to roll back the migration and to update all your servers. And however, during the update, you will have mismatching versions, meaning that you have downtime. So it can exacerbate in rollbacks, even though you're fine with downtime. That's the big message. The solution we will be looking at here in this workshop is solution number 2, avoiding backward incompatible migrations. If you want to avoid downtime, you just don't do them, basically. So that happens in 2 steps. First, well, you just don't do them. And how can you ensure not to do them is by using the appropriate tooling. It's hard if you're reviewing the code of a coworker who will adding migrations, maybe many migrations, to have a look at all of them one by one and to know which one will be fine, which one is not. So there is some tooling to help us with that. And the second thing, since you still want to drop a column at some point, or as a not null column, is to do them progressively by doing only backward compatible migrations and ensure that you have no impact in actually having a hard constraint. So how to detect Django incompatible migrations? There's a little tool called the Django Migration Linter, which main goal is to detect backward incompatible migrations. So it's pretty easy to install. We'll pip install it, add it to the installed apps, and run this management command, lint migrations. Let's do that. Let's jump right in. Let's stop the server. We'll pip install Django Migration Linter. Okay, that worked. Let's go into our editor. We'll go into the settings, which are in the migration workshop settings PY. Let's go into the installed apps and add the Django Migration Linter. Let's save that. Perfect. And that should be it. Let's Python manage PY lint migrations and see what happens. Okay, the linter went on all of our migrations, the 4 we have, and it checked for each of those if they are backward compatible or not. So let's look at them. First one, the initial one, creating the table, it's okay. Creating the table is fine in the sense that previous code couldn't possibly be aware of this model and trying to insert something. So that should be fine in this case. Migration number 2 increased the size of our name from 25 to 100. So here the linter is saying there's an error. It's altering columns, but the little note is added. It could be backward compatible. You may ignore this migration. Why is it saying this? Here in our case, we went from a length of 25 to 100. That is actually backward compatible because the previous version of the code wouldn't try to add a name that is longer than 25. So if we first increase the size, the previous code would still work. If we reduce the size, however, it wouldn't be backward compatible because the previous code would try to add a character of length 80, and we would reduce the size to 25. So the database would not accept a string of length 80 in this case. That's an example for strings. Same goes when you're changing the type of your column. If it's going from a string to an integer or an integer to a string, one of those is backward compatible and the other one is not. And basically, the linter is not smart enough to detect fine-grainedly if this change is okay or not. So in this case, we know as developers that this migration is fine for us. Migration number 3. There's an error, not null constraint on columns. Yeah, we know we added the plant here, which is not nullable and has no default value on the database. So that's fine. And number 4, we're dropping the column, the plant here. Yes, we are. And not null constraint, which is the planted on date field we added, which is also not nullable. So we understand the outputs. So let's jump right into it and try to fix all that, right? So case number 1. Let's try deleting the column. So generally, you would do that in 2 phases. You would first make the field not used and accept null values, so that you know it can be dropped safely in a later deployment. There is some tooling to do that, and we'll look at it. It's called Django deprecate fields, which is there to do exactly that. You will mark a field as deprecated instead of deleting it. And this will, the package will also log when this field is actually accessed, so that you know it will raise a deprecation warning, so that you know that something is off and you shouldn't, and that you shouldn't drop it just yet. So let's try and rewrite the last migration to see if we can avoid dropping the column using this little package. I'll go back to the terminal. I'll start by unapplying the last migration since we already dropped it. We dropped the plant here column. Let's add it again. So I'll migrate back to the version 3. So we unapply the migration number 4 here. I'll remove it. I'll remove trees, migrations 4. And we're going to edit our model. Let's go back to our model file. And here we now add again our plant here, since we don't want to delete it. We just want to mark it as deprecated, since deleting would generate downtime. So it was a positive integer field with a default 0. And we're going to import from Django deprecate field, which we didn't install yet. We'll install it just after, deprecate field. And the way it's used is that you encapsulate your field in this function. So it will be marked and overridden by the library. So let's save that. Let's pip install the Django deprecate fields library. We'll install that one. And now we should be good. Let's make the migration where we don't drop the field this time. We see that it added the planted on field and it altered the plant here. So okay, let's migrate. Nothing else to do, right? Let's move on. Let's migrate this. That worked. And we can now check maybe through the SQL migrate command what it actually did. So trees or migration number 4. And we see that the plant here, we actually dropped the not null value. And additionally, this tool will now log, so you can detect easily when this field is used, even though it shouldn't. Now, if we link the migrations again, we'll see that migration number 4 is not dropping the column anymore. Cool, we're one step closer to making the linter happy. Let's go to another case, which is often a bit more interesting. It's to add add a not nullable column. So you would generally do that in a 3-phase process, where you would add a nullable field. Then you would ensure that your code always sets this value, so that you know as a developer that it cannot be null, and the code before the migration will always specify this value. And then when you are 100% sure, you make it not nullable. Or you can use a database default when that is possible. So we said if it's a third-party API call that inserts default value, you might want to do the first strategy and keep this default value on the application side. But you can propagate, if you know what you're doing, you can actually have this database default on the this default value on the database. two possibilities. Either we add it manually or we add it with some tooling. We'll try both here in this case. Let's try adding this manually on our planted on date field here. I'll go back into the migration. So let me open up the editor. I'll go and edit the migrations file, migration number 4. And in this case here, we'll add a custom SQL statement ourselves. So that, okay, I'm running SQL, and here I'll copy paste it since this is some live coding. So here's the PostgreSQL statement to add the default value, which is now. So that's the current date, so that we actually have the default value on the database. So I'll save this, and now I have the default value. If I migrated this, we can lint the migrations to see if the linter detected that correctly. We see that there's a warning now for migration number 4, which says that the run SQL data migration is not reversible. Oh, good catch, Linter, thanks. Indeed, if I try to undo this migration, it would crash on the run SQL. So we could define no op, since just after that we should drop the field, but let's do that cleanly and actually do a drop default to reverse this operation. And here we go. I'll save that. And now we have a fully run SQL operation that should work fine. And if we run the linter again, migration number 4 is all set. Let's try to get all our migrations working. So at least backward compatible in regards to the linter. So migration number 4 added this plant year with default value 0. Here we'll use something else to try to add the default value. We're going to pip install a package called Django add default value. Django add default value. I'm going to go back to our migration, this time migration number 3. And after the plant here, we will actually add a new operation that will add the default value in the migration. So I'll add the import that goes with it. So from our library we just installed at Django default value, I'll import add default value, which is a Django migration operation, custom one, that is here to add a default value to the migration. Why would that be more useful than doing it manually? Well, before we had an alter column statement, which might be specific syntax for PostgreSQL. You know, the now function is maybe specific, but Django can handle multiple database vendors or even multiple databases at the same time. So this is very specific to one. And if you wanted to change, then you would have to rewrite them potentially. Whereas this package will generate the correct syntax for you depending on what database you're using. So this is just defined as the migrations above. I'll just copy what's there. So we add a default value to the model that's called tree, to the column that's called plant year, with the value, well, we define 0. We'll save that. We'll lint the migrations again. And see that this time migration number 3 is now okay. We added the database default value, so it's not backward incompatible anymore. And now, since we also know that migration number 2, there's written error, but we know it's not an error, we're aware of what we're doing. We also added this one, and as the linter suggests, we're gonna ignore it. So we'll add another custom operation from the linter itself. From my Django migration linter, we'll import ignore migration, and we'll just add that here as a first operation. It's a no op, it will generate no SQL. It will just tell the linter, hey, please don't lint me, I know what I'm doing. And if I lint migrations one last time, now they're all valid and one is ignored. And well, with this knowledge, we now know, right, that all our migrations are backward compatible. We have the appropriate tooling to detect it so that we don't have to think about it every time we write migration. So it's automated, and automated is often a good thing. And we're going to avoid with this now the annoying cases during development or even during deployment in production, basically avoid downtime. So the idea would be to make this, let's go back to the slide, this linter happy. And that will prevent this downtime just by automating the process on detecting backward incompatible migrations. For this workshop, I on purpose didn't use SQLite because all the versions of Django and SQLite are actually generating a different type of operations. You could try it yourself running the SQL migrate on the migration number 2 we had with the database SQLite, which is already defined in the settings. And you won't see the one-liner you expected. For SQLite, the way it was handled is that it would create a new table with the new schema you're waiting, the new state that the model is expecting. It would copy all the data inside of it, drop the old table, and rename the new one. So that's much harder for the linter to detect if the change is backward compatible or not. So that's why for this workshop we use PostgreSQL, and MySQL has the same cases in here for this workshop, but that's the reason we didn't use SQLite. Okay, nearly out of time. It's perfect. Let's sum up what we discussed and seen. So migrations are super cool and useful. They have some pitfalls, but if you're aware that we need the synchronicity between code and database, and that it's hard to achieve during production deployments because of backward incompatible migrations, well, you have some techniques to detect them and to avoid them so that everything goes smoothly. So it's all about your environment, right? Your constraints. If you know that you have to avoid downtime or you have multiple versions running in parallel, well, if you know these answers to these questions, you know how to avoid these migrations bugs now. I hope you learned something. Thanks a lot for listening to me. And I'll be available for face-to-face and questions on Slack or on whatever other support. Thanks a lot.
You put so much effort into this backwards compatibility because you have different versions on the same data running.
Yeah, at some point, I worked in an environment where we had this constraint. This very example, we were selling a stable version of the same SaaS software, but also a version where we added our features and sprints and everything. And they both targeted the same database since it was shared data about some, just business data that had to be known by both. And we didn't want to duplicate the databases at that time. So we were always breaking the stable version because of these incompatibility.
Yeah, I understand. Okay. So then I get this point. Yeah.
But
cool.
It can also happen if you just have not one. I mean, if you have many servers in production, this also happens because you will have a mismatch when you're deploying the database and your code. It won't be at the exact same time, so you will still have downtime at this point if you have backward incompatibility migrations. So it's not the only case where this actually makes sense. I don't know if that's clear.
If you can ensure that you, as in the other talk, the other guy, I forgot his name, was mentioning that, yeah, maybe, that all those operations that delete attributes, you can shift in another release. You can maybe handle this, but this is not the case in your situation. And
well, it would be making the change in multiple releases, basically, ensuring you're not using it. And then it's Marcus discussed it very well, saying, I'm the engineer behind this. I know what I'm doing. I know this column is not used. I can delete it. And doing this, well, one release at a time, knowing what you're doing, that's the best possibility here.
Yeah. Understood. Cool. Thanks a lot.
Thank you. Any other question or something else you want to talk about?
Hi, I wanted to ask, when the project becomes very large, is there a way you can just remove all the migrations and just generate the new ones? Have you ever tried that?
Do you mean squashing all your migrations into one? Or do you mean specifically for the linter I showed in the workshop?
No, not the linter. Actually, it's beyond squash. After one squash, you can't even do another squash. Um, it says you have to undo the previous squash and then do the squash, I believe. So I have a project which has squashes, and it has hundreds of migrations. And what I want to do is for the migrations to start over. So have you ever tried anything like that? Any experience with that?
Completely trying starting from scratch. I didn't try that yet. I know someone has started to work on something similar of trying to remove all migrations and starting from new migrations. But I don't know where this project is. I think it's on GitHub, but it's largely abandoned. However, for your squash migrations, you should be able to squash again a squash migration. If when you squash them, it's explicitly marked as, hey, this migration is a fusion of a merge of all these ones. And once you apply the squash migration and Django is aware that it exists and it's substituting all the others, you should delete the old ones, and the squash migration should be marked as you should remove this dependency. And then Django isn't aware anymore of, hey, this is a squash migration. So it's just a common migration as any other one. And at this point, you should be able to squash it again and to redo the same operation.
Okay, so I have to remove the dependency and then it should work.
Yeah. I don't remember exactly the attribute name that's in a squash migration. But if you remove that and this thing saying, hey, I'm depending on other migrations, then that should work, I believe.
Okay, sounds good. I read that to restart from scratch, what you have to do is delete all the migrations, create the new ones, then run a fake migration that you are at the same level so that the database thinks you have applied all of them, and then kind of do it. I've never got to try it.
That would work, but you have to be careful about your data migrations, your custom run SQL or your run Python code, since if you delete it and you make migrations, they won't be there. Maybe they're adding some default data you always want or some indexes that you always want in your database. So just be careful with that, since squash migration will keep them, and just deleting the migration file it will be lost.
Yeah, okay. If there's no other questions, I have some more.
Oh, thanks.
Okay. So I want to ask another thing.
Yeah,
Many
go
times
ahead.
I have to do some changes in the database. Like I have to, when I'm doing a migration and I've added a column and that's a computed column, I have to compute the values. In that case, what I do is I create an empty migration and run the command either as a Django code or as a SQL to do that as a part of the migration so that it goes on. Is that a good way, or do you recommend not doing it that way?
Marcus discussed on this 2 days ago, and he had a good point. It's the migration process is often blocking for your release. So if you're doing a data migration, computing a value on a very large table that needs to be locked to compute them, you might have a migration that will take a very long time to run, which might be blocking your release or locking a table that's critical or not being able to acquire a lot, the lock on the table. So in the migration, you often have some critical path which will be acquired. Whereas if you do what suggests the Marcus, a management command, well, you can run that at any time you want and maybe do in batches the update of your computed column. So it depends basically on the size you expect and the execution time of your migration, I'd say.
Okay. Yeah, it's a balance, I guess, but sometimes you can't do the migration command because your database state depends on it. So if you start the application without data in that column, it might fail as well. So
Yeah, that should be a migration, I guess. If it's a requirement to have,
yeah,
migration sounds like the best option here, to me at least.
Okay.
Any more questions or remarks?
No, I really like the linting tool that you told about. The add default, that's also good. I've never tried these. We never really focus on these things, I guess. Migrations are kind of like a stepchild. They just exist.
Well, you don't use them until you have to, until you run into the issues and ask yourself like, hey, what did I do wrong? I just added the column. Why is everything crashing?
Yeah.
That's the point where you say, okay, let's think a bit deeper about it.
Yeah. No, that's all I think. I did have one problem earlier, but that's probably not applicable here. That was using Django tenant schemas, where you have to run migration across a lot of schemas. And if something fails, then you're in the middle where half of the tenants are done and half of them are not done. It's kind of a really messy situation. So
I'm not an expert on the tenants, so I'm not sure I would be able to help here.
Yeah, I understand. Well, thank you so much for this session. I really loved it. Thank you.
Thanks, cool. That's nice feedback. Someone else wants to ask a question or has a remark? What is useful or not?
I definitely want to look more into that because currently it's not an issue, but as we are also providing APIs which have to be then downwards compatible, I think we will run into the same situation, and pretty good pointers. Thanks a lot. Yeah.
Cool. Okay, well, thanks for this feedback. That's nice. Okay, if there's not any more question, then I'll leave the Jitsi. Thanks a lot for listening to me, and yeah, have a good day. Bye-bye.